In this video, I'm going to demonstrate supervised learning through Excel. Well, it's going to be a hybrid a little bit, but what we're going to do is take some training data and try to determine anomaly types using that training data. So we're going to train a model or build a really simple model based on some training data, and then we're going to take that training data and look up and see if a given row would be classified as an attack or not. We're going to use that UNSW NB15 data set. I'll link it, and you should have access to it, but we're going to have the training CSV and the testing CSV both involved here in what we're doing. Okay, so I've imported that the training data set. That's the UNSW training NB15 training data set, and we see it's all here. It's comma delimited, or CSV file, and so we have all of those rows here for our enjoyment, and we can see all types of different things about it. I'm going to scroll all the way over to the right, and we see attack, category, and label. And it's that label that we care about, because when it's labeled 0, it's normal traffic. When it's labeled 1, it's something that's not normal traffic. So let's find one of those rows. I know they exist. There they are. So we see things labeled 1, and those are all not normal traffic. Those were classified as not normal. So what we want to do first is just get the normal data out. And because we don't want to train with attack data, we want to train on what normal data looks like. And so I'm going to do that here off screen. And basically what I'm going to do is, and I'll link the script in, but basically what I'm going to do is take a script and get only the normal rows. Only things that are labeled with a 0 is really all that I care about. And yeah, so we'll do that here. And I've already done that off screen. And again, it's delimited, and it's delimited with a comma. I'll click finish. I'm going to live dangerously here, and then let's import that right where we have it. Okay, so now we have that data, and again, all of the data is there. And if I look at the right-hand column, I look at those labels, they're all going to be zeros all the way down. I have no data that's not normal, or that would classified already as normal within here. So that's my data here. What I'm going to do is just get rid of this spreadsheet, because Excel doesn't like to, it's going to be a little bit slower if I keep this other spreadsheet or this other sheet open. So I'm just going to delete that sheet entirely. We won't need it anymore. Yep, get rid of it. And then this data, I'm going to rename this as normal. So then it's easier to reference rather than sheet 1. And it makes it easier for me to remember what's on this part of the spreadsheet as well. So that's the normal traffic again. I've just taken out, and we only have rows that are considered normal now. I think there's about 56,000 or so. Yep, 56,000 rows. Well, 56,001, but that first one is just the labels within there. All right, so what we want to do is try to find something in this data that will tell us a little bit more about whether a row would be classified as normal or attack. And we can't really do that from where we are now, but what we're going to do is kind of cut through some of the math here and give the math, and then where we'll eventually get to is a Python script for this, but I wanted to show it the manual way just because it'll be a little bit more intuitive, I think, to do it this way rather than just a bunch of Python code and then it does some magic and gives you some numbers. So let's go the long way around here in this video. And I'm going to open up a new spreadsheet, and in that spreadsheet I'll rename that to compute, because we're going to compute some values within here. I'm going to choose some columns that are just easy to get to. So columns B, F, G, H, and I, the duration and the packets and the bytes. Those are all numeric. We don't have to worry about encoding them or converting them or doing anything like that. So first thing I'm going to do is just calculate the mean values or the average values and also standard deviation for the entire row of duration. So I'm going to label that, well, I guess I could do it a couple different ways. Yeah, let's do it this way. All right, so there's the average of the B column. Unfortunately, it's not the C column that we're going after, so I need to change this to the, I think it was the F column. Let's just make sure because I'll never get that right. Okay, yes, it's the F column, but then I go FGHI, so I can just copy and paste from there. Sure, I can do it I could do it the long way if I'm careful, but I'm not careful, of course. So Control C there and Control V there. All right, let's do standard deviation as well. And again, I have the same problem where this is going to be the F column. And let's copy that over this way. All right, so now I have the mean and the standard deviation of each one of those. And we're going to go back to that normal table or that normal spreadsheet. And I'm going to add a column over here in the AT column, and that is going to be distance. So we know where the mean is, we know where the standard deviation is on average for the entire rows of data. And I'm going to basically do the same thing here. I'm going to paste in a formula, rather long formula. And so let's grab that in the clipboard and we'll paste it in here momentarily. All right, so I'm going to paste that formula in and I'll expand this so we can actually see it. What we're doing is comparing this row of data, specifically this row of data, row 2, and even more specifically, just these 5 points, the 5 points we talked about earlier, duration, what do we have? Duration, packets, bytes, and those types of things. So just those 5 data points, we're going to compare those then to the normal or to those averages that we computed within the other spreadsheet. So before I go too far, I'm just going to press enter here. Whoops. Yeah, see, I messed something up. All right, let's try to paste that again. There we go. So now I can explain that formula again. It's grabbing those values from the compute spreadsheet, the sheet that we had earlier, and using those there. I'm just going to change that. So the values that we had, basically averages for those entire columns, that duration column, and then we computed standard deviation from there. So we have a normal, sort of think of it maybe like a bell curve. And this is the distance from that normal, from the center of normal. What's the distance for this specific row from the center of normal? I'm going to copy that formula to the entire spreadsheet. And now we have the distances for every single row, the distance from normal for every single row. And remember, all of these rows are classified as normal. And so ideally that distance is going to be rather small. Next thing we'll do then is add our threshold. At what threshold number do we think that something would be an attack versus normal traffic? And in order to calculate that threshold, I'm going to use another formula here in Excel, and I'll paste that in as well. And the formula that we have is the percentile formula. And again, we're looking at that normal spreadsheet. We're looking at the AT column, and I'm looking at the 99th percentile. When I do that, I come up with 12.158 as being our threshold for what we'd consider to be not normal traffic. If we look at the normal spreadsheet, everything that's already been classified as normal, we're seeing values that are significantly smaller than that. I think I did see at least something greater than 1 there. Yep, sure enough, there's a row that's greater than 1 within that spreadsheet. Here's a row that's greater than 6 within the normal spreadsheet. So things that sort of deviate a little bit from what we would consider to be normal traffic even within the normal spreadsheet, a part of our training data. We're going to then set up a spreadsheet that we can use to test some packets out. And I'm just going to manually type things in here. We only have a handful of them to type in. And let's do this. Then let's calculate the distance here within this spreadsheet. So we're going to do that same distance calculation that we made before, and we had in column AT. In this spreadsheet, we're going to do that same distance calculation for our new spreadsheet. So let's rename this, by the way, while we're here, and just call it test. Where I'm going to make that distance calculation down here, and we'll see why momentarily. But for now, what we're going to do is grab that distance calculation once again. Whoops. I'm going to grab that to the clipboard and then paste that in as well. It's probably going to error out here at first just because I don't have anything, any data in there currently. So I'm guessing I'm in for an error, but I'll have to make it through. Oh, it gave me something. Oh, yeah, that's right, because it's actually grabbing things from the normal spreadsheet, and it's preventing divide by 0, by the way. That's what the max formula does, and this little bit of syntax that you see there, it's preventing that error from happening. I got ahead of myself and thought for sure I was going to get an error, and I probably would have if I didn't have that wrapped around. But I do. So what we're going to do then is fill in some values from a different spreadsheet, from some of the test data. Let's go try to find an attack and see if we can get that distance to get above 12, which is what we've computed to be the threshold, right? And in fact, what we can do is just add something in there into this code to figure out if it's attack versus normal. So let's do that, because that's I suppose the next step. Whoops, I need to do it up here. I don't remember what number that's in over there. Let's go see if we can select it. How nice will this be for me today? It will be okay, but I need to go back here and what's it done now? Come on, Bill Gates. What are we trying to do here? All right. B6. So let's put $signs in front of that. B7 it is actually. And so then if it's greater than that, then we'll classify it as an attack. Otherwise, we'll classify it as normal. Oh, good. No error there. And we see since that distance is less than the 12 point whatever it is over here, because that distance is less than that, we determine that this traffic is normal. So I'm going to go grab a value from that spreadsheet of test data that we have. And let's see, how can we do that so you can also see that happen? Okay, so this is the testing set. I loaded it off camera here a little bit, but this is essentially that testing set that you can get from UNSW, and we can see that a lot of the things in here are labeled as attacks. And so let's just grab one of these rows within this data, and I'm just going to pick one at random here, 2180. ID 2180 in row 2181. And so let's fill in some of those values into our spreadsheet, our test spreadsheet. So 1.262 for duration, 1.262, right, is hopefully what I'm thinking. Yeah, 1.262176. Don't know how significant those last three are, but let's might as well do it anyway. And then we have columns F through I. So 10, 6, 5, 18. And then, where are we? 10, 6, 5, 18, 268. And you can see that distance is recalculated as I go here, as I fill in test data. So those, when I fill in that test data, even though this is classified as an attack within this test data, we still classify it as normal. So what that's telling me as an analyst, and it took a while to get here, but here we are. This is the most important part. What it's telling me is that the columns that I've chosen, or the features that I've chosen, aren't very good at discerning whether we have normal traffic or attack traffic. So what that's telling me is I need to find other columns. I need to find other features in our data that help to discern normal versus not normal traffic. One way that I can do that, well, there are a couple ways that I can do that. The first way that I'm going to do, just because we're sort of here in this manual process, I see this packet here, and it is row 1241 of this data, and I see it there, and 13.939, and that is 1241. So let's grab some of these values from that row, 1241, and put them into our test data. 37.955 for duration. And we can already see when I put 37.955 for the duration that that distance shot up significantly, whoops, in the normal data here. And then 360, 746. Whoops, wrong spreadsheet. 19202 is the next value. And the next value after 19202 is 1087890. And now suddenly with those 5 things, we see that we have an attack. But those are obviously extreme values, because even though that was classified here as normal, it's still pretty far away from what we would consider to be not normal. So we have to get to an extreme outlier in order to have something classified as an attack. So what we might do next then is add more features into our calculation in order to simply determine what is adding on to, or what best describes attack data. What does attack data look like? Are there different features within our data set that might discern an attack versus not an attack? STTL, DTTL are 2 good ones from this data set that help to discern whether things are attacks or not attacks. And so we might add those in to our calculation, and then we can recalculate from there. So in order to do that, what I'm going to do is copy and paste those here. I'm going to simply grab this. Where am I? I'm in the normal spreadsheet. I want to be in row 2 just because my life will be easier then. At least I think it will. So let's go in row 2 and copy to the clipboard just that little piece and paste it in. Now, let's see. If I want to add STTL and DTTL, that's columns K and L. So I need K there, and I need L here. These are going to be wrong momentarily. I need to go change things in that compute spreadsheet as well. So let's go to that compute spreadsheet. We need to add STTL here and DTTL here. And then we're going to do the same thing here, except we can't just go over one row. We always have to make sure things are in the right place. And it was K and then L. And so we'll do the same thing here, change these to K and this to K, and change that. So we have standard deviation for columns K and L in the normal spreadsheet. And here is our normal spreadsheet again. And now I need to change this to whatever it was in compute. Oh yeah, I know, that's wrong. Don't do that then. All right. Don't listen to me. There we go. It was it F over there? Let's go see what we have in the compute spreadsheet. It was G. Naturally, I was off by 1. So G and H are what those translate to now. So this is G. And this will be H. Again, those values are coming from here. We could compute all of that right here, but it's nicer from an explanation standpoint to have those values in a separate sheet. It just makes things a little bit simpler to show some of the behind the scenes, which is the goal for this video. All right, so we have I, K, and L are now going to be added, and we see that distance change significantly now once we've added those values in. I'm going to copy that calculation all the way throughout the spreadsheet. And we see those distance values have now changed significantly simply by choosing 2 more features. We chose the STTL and the DTTL features, and we can see that those now that our distances have changed significantly. Let's go back to the compute spreadsheet. Notice that our threshold hasn't really changed significantly, but let's go back to that test spreadsheet. I'm going to add columns for STTL and DTTL. And I think I was in row 1241. I want to say I was in 1241. Or no, I was in 2180 because we were looking for, oh, that was a different spreadsheet or a different sheet. I was in the normal sheet for 1241. Here I'm in 2181, 2180. So I'm going to recreate these values, 1.262. And 10, 6, 518, 268. And the STTL and DTTL are 254 and 252 respectively. Okay. I need to do the same thing that I did here. I need to do that same copy and paste that I did in the other sheet in order to calculate this out. I still don't think we're going to change. I don't think we are going to have the right combination of features here, but I just want to show you at least how these numbers change as we go. So let's see, column F2. So I wouldn't be surprised, based on the row that I chose at random, I would not be surprised that we're not really going to change anything here. But it's still a good demonstration of choosing additional features and trying to find the right combination of features that will help us to get to that threshold that we're looking for, reach that threshold with an actual attack packet. I need to grab, it's not I anymore in the normal spreadsheet, right? It was K and L. And try to tell what's an L and what's an exclamation point in that font. That's interesting. Okay. And then I need to add L over here, which is going to be challenging as well. Not only because the monitor is about 40 feet away from me, it seems like, but the font isn't helpful either. All right. So now we see that distance went over 3, right? By changing it, I again picked that row at random out of that test data set, but we added 2 more features. We added 2 more columns and the data from those 2 more columns, and we see that distance, it was like 0 point something before, I thought. Now it's 3.00. We're still determining this data to be normal, but it's interesting because notice how that changed. So if I kept looking through this data and kept trying out different features, I might find a combination that helped to classify things better or classify things more accurately. The other thing that we can change, the other thing that we can tune here is my threshold is looking for 99th percentile. meaning that only traffic that's outside of that 99th percentile will be classified as an attack. Notice the threshold then, that distance from the normal is 12.21. If I change that threshold, if I change that percentile, say down to 75, now suddenly my threshold, it only needs to be 2.25 away in order for a given row to be classified as an attack. And again, so now I can suddenly go over here, my distance, I didn't change any of these, no trickeration going on here, that distance calculation is still the same, but now our determination is attack because I changed the threshold here. I changed that percentile for our threshold. As I change that, so if we said, well, 75% is going to give us too many false positives, let's change that to 95%. Well, we can see now that it is 3.45. As we go with that 99th percentile, that really makes that threshold huge. So as you're training models, that percentile is something that you want to keep in mind, because that'll change the false positive and false negative rate on training. That'll change the accuracy of how well things are being trained. So that's definitely something to keep in mind. So hopefully this video was helpful to show or demonstrate some of the things that are happening behind the scenes when we're trying to train a model. We're trying to pick features that have significant impact on how we classify something, whether it's classified as normal versus attack, and so on. And that's really the heart of building AI, is trying to discern meaning from what's happening, or the context of a conversation, or the context of a single row, a single packet of information. We're trying to glean that information and gather it, what lends itself, what helps to score things higher to make us determine whether it's normal versus attack, to try to infer what's exactly happening in that network flow or in that conversation for a generative or a chat type AI that we might build.